Hey guys, this is a project that I was doing recently. This is a Sudoku game or solver, you can say. Uh, this is made with React. The front end is made with React. I purposely made it so that I can split it with React and Node. I wrote the backend on Node, so it has some functionalities. You can say I can create a random Sudoku puzzle every time, and then I can solve whatever puzzle is at the moment on the screen. And if I am solving it manually, I can validate whether or not the current version of my puzzle is valid, or is it a valid solution. And if I try to solve it at this moment, I know that it is unsolvable because one occurs multiple times in the same row. So if I solve it now, it will obviously solve it perfectly fine, and I can clear this. And I have some API calls it makes to the backend. So it has 3 different API calls. It has this endpoint puzzle, solve, and validate. If I go to my backend, it has some requests set up here. All of this will make in these videos that you'll see. So I hope you'll enjoy this fun little project, and see you then. Hello everyone. Today it's been a long time since I uploaded the last video, almost like more than 2 weeks. Today, as you might have seen, if I complete this project, what we are doing is we are going to make a Sudoku solver, and I'm going to do that with React and Node and connect them using Express. Yeah, you can do that using only React, but the reason why I'm doing it with Node and React is to practice you can say the code that REST API, like GET requests, the POST requests, like that. So what we will be doing is we'll be writing a backend with a Node, and then we will be creating a front end with React, and then connecting those two. This may be a multiple part video. The first thing that I want to do in today's video will be writing a simple Sudoku solver, and probably a creator also, right? Something to create puzzles and something to solve puzzles. So to solve puzzle, we have I have this After Academy's blog post, and it you can read this article, and it is very easy to understand how they are doing it, how the algorithm works. It also has a pseudocode, and also lists some steps how we can write our program. There may be a little some minor differences in what we do, but we'll mostly follow this. So what I have here is you can say empty Sudoku board, and to start with, I'll be finding a solution to this Sudoku board, right? So the first thing is for the first step is make a list of all empty spots and select a spot. The second step is select a spot, place a number between 1 to 9 in it, and validate the subgrids. Subgrids are horizontal rows, vertical columns, and the 3x3 grids associated with that spot. So it is very easily seen here. What this algorithm is doing is it trying to put something in for example, here it will try to put 1, and first it will check whether or not this row already has a 1. If this already has a 1, it will not put 1 here. If it doesn't, then it will check this column. If this column has 1, then it will not put it here. Otherwise it will otherwise it will check the subgrid, this subgrid, if this already has 1. If none of those have 1, then that means 1 is a valid number to put here, and we can put it here. Then we'll move to the next empty spot, and we'll repeat our logic. So without further ado, let's dive into our code and write a function to solve our puzzle, or we can say I'll call it grid, since it is a 2x2 array, and the 0 represents an empty spot, and if we put something in it, we'll just of course put something in it. So to start with, let's we'll have to iterate over this grid. We'll start with row is equal to 0, row less than, you can say 9, or you can say grid dot length, it doesn't matter, since I'll be only doing it with for one thing only, for one size only, that will be 9 by 9. And then we will have column. Okay, so we'll iterate over this, and then we'll check whether or not the current column is an empty space. How we can do that is we'll just say grid row and grid column. If this is if there is 0 on this spot, that means it is an empty spot. Then we can try to put something in it by checking whether or not we can put in it. Like for example, let's write another function. We can say guess is equal to 1, guess less than 10, guess plus plus. And we will what we will do here is we'll check, we'll have some other another function. We'll check if is valid place, and we'll provide it with our row and column, and then we'll provide it with a number, and then this function will return us whether or not we can put this number into this row and this column. We'll probably need to send it our grid also. It will check this grid and on this row and on this column, and it will check whether or not we can put a number on that spot, this number. And if we can just simply say that grid row and column is equal to that guess, right? So simply we'll just put that number there, and if not, let's go back to our previous to the algorithm that we are following. So we are currently here. We have find a spot where we can put our number, and we have put that number there. What otherwise if I go through all the numbers from 1 to 9, and I cannot put anything there, anything on that current spot? What do I do next? So that's the step number 3. If any of the constraint fails, abandon that solution by backtracking to the previous state and repeat step 2 with the next number. Otherwise, check if the goal is reached. What does this mean? For example, if I'm trying to put something in here, and I run out of all the possibilities, that is from 1 to 9. If I don't put anything, if I don't find any valid number to put here, I will have to go back to my previous number and then change this from 1 to 2, and then try again the next one. So how can we do that? So the one thing is for sure, that since it is a backtracking algorithm, that we will definitely use the recursion here. And if you have not seen the previous videos that we did on recursion, here is a good one, that is a maze generator. This is also done using the backtracking algorithm. Definitely a must watch. Let's go back to our current video. Okay, so in our else, what do we want to do? We will put if we don't find anything to put in here, so what we will need to do is we'll need to put the 0 back into the place of what we are trying, and actually we don't want to put it here, because at this point the row and column is the same that we are trying, right? We don't want to do it here. So first of all, we'll have to check whether or not first of all we'll have to call it again for the next row and column, right? So we'll call this again, and with the grid that we have already mutated. So we have put something in the first place, then we call the solve algorithm with the new grid that we have already mutated here, and then it will obviously try to go to the next empty position. And if that if this fails, then we'll go back and put the no, if this fails, we'll go back and put the 0 here. So what does it mean? We'll try to solve it for the next one, for the next empty position, then the next, then the next, then the next. If it works on every works perfectly well for every position, then we'll not ever go to this particular command or the line of code that you see here, but if at some place this fails to put any number on this current row and column, we'll just put it will not go inside here, and it will return something. For example, we'll say return true here. If it doesn't return true, then it will go back to the previous one and put 0 there, and then put 0 on this one and then go back to the previous one, right? And if all of these fails and we reach some you can say, if we go through every possible empty space on the grid, and then even then it fails for the last one, then we'll just simply return false. What does it mean? It means that we don't have any solution for our you can say the for our grid that we have provided it. Otherwise, let's just add a return true here, but I don't think that will ever reach here, because if we find a solution, it will just simply return this. But if we go through the complete array and everything is filled, that means that there are no more empty spaces, and we will just simply return true. That means that we have solved our grid that we provided, the puzzle that we provided it. So what does it mean? What does that function do? Let me reiterate very quickly. So it will receive a puzzle, it will mutate that puzzle to find a solution. If it doesn't find a solution, it will return false, and at that point this grid will be exactly the same that we provided, because we are resetting these states to 0 here when we don't find a good solution. Otherwise, we'll mutate it to a perfect solution and then return true. So we'll have to keep in mind that whatever puzzle we provided, it will mutate it. So whenever we solve it on something, for example this board, we will have to do something. For example, for I think we'll just copy it to another grid and then provide it here. So let's call this solve function on our board that we have defined here, and then try to console.log our board here. Let's try to run this and see if it works. Okay, so we have some error. Oh, obviously I forgot a major part. So here we are checking whether or not this place is correct, but I never made this function. Let's go ahead and write this function now. So this function is valid place, and it receives a grid, receives a row, and receives a column, and receives a number to check whether or not we can put this number in this grid, on this row and this column, right? So how can we do that? So there are 3 basic rules of Sudoku, that a number cannot repeat in a row, and it cannot repeat in a column, and it cannot repeat in a subgrid, that is the 3x3 grid that we see here. Okay, so the first thing that we want to do is let's check whether or not the current row has that number. Okay, so we'll iterate over the current row from start to finish, that is the size of 9, and we'll check if grid this should be like this, and this column is equal to this number. If it is that, if there is there is a number in any of these rows in the same column, we'll return false, right? We cannot put this number, because this number on this place, because in this column, in one of the rows there is this number, right? So this will give me this will check the row, this will check every row in one column, and then we can do the same thing for the column. And here we'll just say row and iterate over the I, and we'll check the row for every column, and if it finds the number there, it will return false. The next thing that we want to do is we want to find whether or not this number is in this subgrid. So to find the number, to iterate over this subgrid, what we need to have is we want to have the starting row and column index for any subgrid that we are trying to search for. For example, if we are trying to look for this one, then we want to have the row and column index of this this starting box of this subgrid, right, which will be 0 and 0. If we are searching for this one, we want to have this, and if we are searching for this, we want to have this one. So how can we do that? I think it will be a simple one. Let's say local box row, and this will be the starting row index of the subgrid that we are checking. And how can we find that? It will be easy, row minus row ampersand 3 ampersand 3. So let me just simply write the same thing for a column, and then I'll explain what I am doing. So this will be column and column. So what I'm doing here is I'm getting this row number and subtracting the remainder of its remainder when it is divided by 3, right? For example, if I'm here, so the row number is column number is 0 1 2 3 4, and I want to have this 3, right? So I can I can subtract 1 from 4, and if I divide 4 by 3, the remainder will be 1. If, for example, I am here, I can divide, it will be 5 divided by 3 will give me a remainder of 2, and I can subtract 2 from 5 and I will still have 3. So this with this little trick here, we'll have the starting row and column index of the current grid that we are in, and then we will just simply write a nested loop to iterate over the row and column, the subgrid, and it will now be I less than it should be local box row plus 3. I'm sorry. It should be local box plus 3, and then we will add the I in it, and we'll have the same thing for the columns. The difference will be the iterator will have j, and we'll have column here. And then we will just simply have the same thing that we had here, provided it will have I and j. And if it finds something that is for example, if it finds a number in that grid, it will return false. But if it goes through all these 3 checks and finds nothing, doesn't find that number in there, will just simply return true. So this is our function to find whether or not we can put this number in this grid on this row and column index, right? So let's run it again. Okay, so we have some kind of solution, but as you can see, it is not looking very pretty. Let's write a helper function to print it nicely. Let's create a util.js. Okay, and we'll have to import it to there. Okay, so let me give me a little time and minute. Why this will initiate package.json, and I'm doing that because I want to use the module type to import and export, and I cannot do that without this package.json. So let's have a util object here, and it will have a function which will be print to the array. It will be a function, it will receive a grid, and how can we write that? Let's say okay, let I is equal to 0, I less than grid dot length I plus plus, and we will write the console.log, and we will spread the current array that is inside on this index, and then we will just simply change the line. I think it should do the trick. And we will also have to export this util object from here, and then we can go to our game and import, if I can spell it correctly, util from util.js. Okay, and if I go here, let's now just call the util.print2d array box, and if I run it again, okay, we are seeing it like somewhat nicely, but I think that it's not a good way to provide it with our puzzle and then just simply mutating that. Let's have another function here which will be copy grid, It will also be a function, but it will receive two arguments. One will be from, the other will be to. It will copy this 2D array. Both of these will be 2D arrays. It will copy this 2D array to this one. And how we'll do that? For let I is equal to 0, I less than from dot length and I plus plus. And okay, so this is important because the way we are doing it, because I'll tell you why in a little bit. So this using this spread operator is necessary, because if I do just to I and this from I, it will not copy the contents of the array, but it will just simply save the reference of this array in this one, and it will still mutate my array, the initial array that I'm providing, which will be from. So I have to like spread that, and when I spread that, the values will be all you can say primitive types, and obviously that they will be transferred to as a new array like this one, and it will be copied via the value, not the reference. So it is necessary to do this, and then I can just say let solution is equal to an empty array, and I can call util dot copy grid on from board to solution, and then I will call the solve on my solution instead of calling on the my board itself, and then I'll print it here. Let's see if it works. Yeah, it works, but what is the difference here is the difference is that I still have my board as it is, right? So we have the logic to solve a given Sudoku, right? But what we have so far done is solve a Sudoku that was empty. So let's now go ahead and write a logic to give us a random Sudoku puzzle every time, right? So how can we do that? An easy way to do that is to first find a solution and then remove some of the numbers from that. For example, I randomly remove this, and so remove some numbers randomly, and we'll be left with some clues, and then we can solve for a solution from there. So let's go ahead and write a function, create puzzle, and to start with, let's have a puzzle here which will be an empty array to begin with, and then we will first make this. So we'll first create an empty 2D grid like this one. How can we do that? We can do that like this, 9 and I plus plus, and we will just say puzzle I, it will be an array of length 9, and it will be filled with zeros. Okay, so this will give me if I return puzzle at this time, and instead of these two, I take in a puzzle from this function now and solve for this. It should give me the same thing, the same result, right? Yep, it is giving the same result because it is essentially the same thing. The difference is we don't have it like hard coded like this one. We are just creating the same thing with this loop. So what next? We can do next is we can iterate over this 2D array, and we'll need nested loops and I and j, and we can just randomly remove some numbers. So how can we do that? We can use the math.random function. If it is greater than 0. Let's say 3, we will do what? We will remove whatever number is present on that position at that I and j index. So it will remove, it will be roughly true. This expression will be roughly true 70% of the time, and it will remove 70% of the zeros of the numbers from the puzzle, and it will return that. So let's see how it works. So it is giving me the same solution. So why is that? why is it still giving me the same solution? That is because if I go here and let me print out the puzzle before and after. So if you see, okay, so it is still returning me the puzzle is a repeat puzzle, and then I print the puzzle, it is still giving me the same thing. Oh, so I forgot to get the solution, sorry. Let's first solve this puzzle and then remove some of the items. Okay, so we find a solution, and for let's remove these also. I'll show you some interesting thing. Okay, so why did it simply, okay, so I get a Sudoku, and I if I run it again, I get, you will think I get a different Sudoku, but if you see closely, it is still the same thing, only the other numbers, for the number that we have here may not be replaced here, but the solution for this will always be the same, because what we are doing here is we are providing it with the same puzzle to start with. So this wouldn't work, because it will always have the same solution, and we can do it, we can clearly see it from here. We saw that it is generating a seemingly random puzzle to start with, but if even no matter how many times I run it, it will always give me the same solution, because we are starting with the same thing over and over again. So we should have some randomness here before we are solving for a solution. So how can we get that? So let's write a function to get a random Sudoku, and to get a, so what we can do here is, let's do this thing instead here, and we will just call this function from here. It should work exactly the same way that we did it was doing earlier, right? Yes, it is. So what we can do now is we can do what can we do? We can now fill one of the rows randomly with some numbers, right, before we solve it. So what it will do is it will always generate a new number, new solution. So how can we do that? We will have to iterate. No, we don't need to iterate over it. Let's just write a single loop, and first let's get a number to put into an array, into a row. And how can we do that? We will use math.floor, math.random, and multiply that by 8 and add 1. It should give me 9, but it doesn't. This math.random function is always returns something less than 1 for me. I don't know why is that, or maybe I'm understanding it wrong, but it always gets stuck on the last element of the row. So I'll just iterate to the 8th point. It will give me enough randomness, but I cannot just go here and put, like, if I'm putting it into the first row, I cannot do this. It might because it might generate this might generate, like, for example, number 2 more than once. So it will put the same thing over 2 times in the first row, which I do not want, because it is against the rules of Sudoku. So before I put it into the puzzle, I'll have to make sure that I have the correct number to put into the grid. How can we do that? We have a function to check whether or not we can put it, the number into the into a set grid on a set row and column, and we can use that function like this one, and until we find a valid number, we will just keep on doing this. And if as soon as we find it, we'll just put it in here, and it should now give us some randomness. And if I run it, do I get anything different? I don't think it is different. Oh yeah, it is different. So you see that now we have seemingly different, you can say, solution every time. That is because we are now not starting with the same thing over and over again, because this puzzle will now have some randomness in it that we achieved with this logic. So that's that. I think this will be enough for this video. It's getting quite long. So what we have so far is, to repeat, we have logic to create a random puzzle, we have logic to create that, to solve that random puzzle, and we have some helper functions that can check the validity of a number that we are trying to put in place, whether or not that fits there, whether or not that follows the rules of Sudoku. And we have some utility functions like printing a 2D array or copying one array to the other. So in the next video we'll do some refining to it, maybe add some logic further, and then we'll move to the front end of this project, and I hope that we can finish it in the next video. So I hope you enjoyed this one. If you did, please leave a like or a comment. If you are not, please subscribe to the channel. Thank you for watching. Goodbye. See you again.